So welcome to today's class. This is Dr. Mahender, Associate Professor of Mathematics in the Department of Basic Sciences and Humanity. So BV Raj Institute of Technology, Narsapur. The course name is Linear Algebra and Calculus. Today I am going to cover how to find eigenvectors of a scale matrix. Now this is the fourth lectures in this module. So the first lecture we discussed the introduction to the eigenvalues and eigenvector. In the second lecture, we covered the properties of eigenvalue, the problems related to the properties of eigenvalue. The third lecture, so we have discussed the applications of the Cayley-Hamilton theorem. Now today, so I am going to cover eigenvector, how to find eigenvector of a scale matrix. Now we can we can do in 3 steps. So the working rule is, first what you have to do is just have to do the working rule first. So working rule. The working rule is the step 1. So write characteristic equation of given scale matrix. The step 1 is what? First write the characteristic equation of the given scale matrix. The step 2 is solving this characteristic equation will get the roots. The roots nothing but are the eigenvalues of the matrix. Finding eigenvalues of a matrix by solving characteristic equation. The step 3 is, so whatever the eigenvalues you will get in step 2, for each eigenvalues we have to consider this equation. Consider a minus lambda I of x is equal to 0 for each eigenvalue. So solving this equation, this equation will get eigenvectors of particular given lambda, given eigenvalue. So we will do in the 3 steps, we will get the eigenvectors. So once again I will review quickly. The first what you have to do, the step 1 is write a characteristic equation of the given scale matrix. The step 2 is the finding eigenvalues of a matrix by solving the characteristic equation. So nothing but the roots are the eigenvalue. The step 3 is you have to consider for each eigenvalue, you have to consider the system of equation. The system of equation is represent a homogeneous system of equation. So solving this equation will get the eigenvector corresponding to that eigenvalue. So now we'll go to the problem. Find eigenvectors, eigenvalues and eigenvectors of the matrix. Finding eigenvalues, eigenvectors of the matrix. The matrix is the first row 1 0 minus 1 1 2 1, the 2 2 3. So this is the matrix. Now you have to find the eigenvalues and eigenvector of this matrix. So what we have to do, the step 1? The step 1 is what we have to do. So we have to write the characteristic equation of the given matrix. And the step 2 is you have to solve it. We'll get the roots. The roots are nothing but the eigenvalues. The step 3 is for each eigenvalues you have to consider a minus lambda of x is equal to 0. So we will first start with step 1. The step 1 is what? To write the characteristic equation. The characteristic equation is det of A minus lambda is equal to 0. So this is the given matrix, can consider as a A. So this is the formula for the finding characteristic equation. But we have the shortcut formula also we have. So instead of proceeding with this one, if you use the shortcut formula, so we'll get directly the required equation. So now I'm going to use that one. So this is because of the 3 by 3 matrix, we have the formula is the lambda cube minus S1 lambda square, S2 lambda minus S3 is equal to 0. So this is the shortcut formula for the characteristic equation. Now what represent S1? Here S1 represent the trace of a matrix. The S1 represent what is a trace of a matrix. What is the trace? The sum of principal diagonal elements of the given matrix A. So the here what? 1 plus 2 plus 3. 1 plus 2 plus 3 will get 6. Okay. Then S2. What is the S2? The S2 is the sum of minors of principal diagonal elements. Sum of minors of principal diagonal elements. So if we have to find the minor of A11, so minor of A22, minor of A33, add these 3, we'll get the S2. Now we'll first compute the minor of A11. So we'll obtain by deleting the first column and first row. So we'll get that one. 2, 1, 2, 3. So minor of A22, similarly by deleting the second row and second column. So we'll get 1 minus 1, 2, 3. So in the same way, we'll get the minor of A33 also by deleting this third row and third column. So that is 1, 0, 1, 2. So we know how to obtain the determinant of 2 by 2 matrix. Suppose if A, B, C, D, AD minus BC. So we'll do this one like. So this is what 2, 3 ja 6. 6 minus 2. 6 minus 2 is the 4. Now 3 plus 2, the 5. Then 2 minus 0. 2. So the 9 plus 2 is 11. So the S2 value is 11. So S3 you have to find out. So S3 is what? Determinant of a matrix. So we are familiar to how to obtain the determinant of a matrix. So the sum of the product of elements of any row or any column with corresponding cofactors. So we usually will take it as with respect to first row. If you take it with respect to first row, so this you have to remember the signs of that row. Plus, minus, plus. Suppose if you take the second row, minus, plus, minus. The plus, minus, plus. So whichever the row or whichever the column you are following, so based on that you will take the sign. So the logic behind this getting the sign is the minus 1 whole power I plus j. Based on that we'll get whether the entry you have to take is positive or negative. We'll do this one now. Now with respect to first row we'll do it, the 1. Yeah. Now deleting this first row and first column, now you can write it 6 minus 2 is the 4. Because the second element is 0, so we'll get 0 directly. But again you have to compute this one, minus 1. Yeah, deleting this third column and first row. This is 2 minus 4 is the minus 2. 2 minus 4 is the minus 2. Now just this is the 4 minus plus 2, 6. Now look at this one. This S1 we got is here S1 is equal to 6 and S2 we got 11 and S3 is equal to 6. Just you substitute in the given equation, the formula will get the required equation. Therefore, the required characteristic equation is lambda cube minus 6 lambda square plus 11 lambda minus 6 is equal to 0. So instead of going with the general formula, if you go with shortcut formula, so directly you will get the proper equation, will get that one. So next what we have to do is, you have to solve this equation. then how to solve the third degree equation? But we are familiar with solving second degree equation. But if at all, if the given equation is a third equation, then how to solve it? If at all, if you are using calculator, just typing this, the coefficient of the third degree equation will get directly the roots. Suppose if you do not have the calculator, then what is the method you have to follow? So first what we have to do is, first by inspection method, you have to find out one root. Then how to proceed with inspection method? Start with 1, check it whether the equation is satisfying or not. Then -1, 2, -2. This is the way of checking of the inspection method. So let's substitute, let us see whether is a lambda is equal to 1 or not, is a root or not. Then check it by trial and error method. Okay. So 1 cube is 1 minus 6 times 1 square is the 1. 11 times 1 is the 11 minus 6. Now look at this one, is nothing but this is a yep, yeah, this is a plus 12 and minus 12, 0. Therefore it is satisfying the equation. So by inspection method we got, therefore lambda is equal to 1 is a root, is a root. So first what we have to do is, you have to find, by inspection method, you have to find one root is a root. So once you get the one root, then you can use the synthetic division formula. So what is the synthetic division formula is, suppose whenever if you have the lambda is equal to 1 is a root, then you have to write like this. Then here what you have to take is, write the coefficient of this equation, you have to write from starting from highest degree to the lowest degree. What is the coefficient of highest degree of this equation? Lambda cube coefficient is 1. Then second lambda square coefficient is the -6. Then 11 minus 6. So this first we have to do it. Here you have to write the whatever the root you will get in inspection, that you have to write. Here you have to take it 0 and add here. This is the way of starting this method. Now then multiply this 2 and write it here. 1 1 is 1. Now we can again add it. This is a -5. Then multiply 1 times -5 is the -5. Then we'll get 6. So 1 times 6 6. Yeah. Now these what they represent, and also this is the one of the clue also I am giving. If you get this last, if you get 0, means the process is going in the right way. So now this whatever we have here left here are the represent are the coefficient of the second degree equation. So lambda is equal to 1 is the root, means so lambda minus 1 is a factor. Now lambda square minus 5 lambda plus 6 equal to 0. Now we are familiar how to split into second degree equation, how to express the simple factors of the second degree equation is, this already I explained in the earlier lectures also. Here the logic is how to choose two numbers in such a way that the sum should be what? The sum should be is equal to the -5. The product you have to get 6, you have to get it. Then choose the numbers. So the numbers are is what? -2, -3. -2, -3, if you add it, you will get -5. -2 times -3, if you multiply this 2, will get 6. So therefore, lambda minus 1 is a factor. This I am writing lambda -2, lambda -3. So therefore, lambda is equal to 1, 2, 3 are the roots of this equation. So roots nothing but the eigenvalues of the matrix. But here you have to do it, everyone you have to remember in the examination also. After getting these eigenvalues, compulsory you have to verify that whether the obtained eigenvalues are correct or not. Then how to verify that whether the obtained eigenvalues are correct or not? For that you have to use the properties of eigenvalues. What are the properties? We have the two properties, you have to check it. If the two properties are satisfied, the obtained eigenvalues are correct. So what are the properties? The sum is always equal to the trace of the matrix. The product of eigenvalues is equal to the determinant of the matrix. If if these two conditions are satisfied, the obtained eigenvalues are correct. Then we will check it now. Now sum. What is the sum of eigenvalues? 1 plus 2 plus 3. that is 6. This is nothing but trace of a matrix. Yeah, this is also verified because also we have the trace, also we have what 6, and sum is also is equal to the second one, the product. What is the product? 1 dot 2 dot 3 6. Now it is equal to determinant of the matrix. So this is also, now look at the determinant also, we got it 6. So therefore these two conditions are satisfied. So therefore, and now we can conclude that, so whatever the values we got it here, they are the correct eigenvalues. So after verifying only, you can proceed to the next step. So next step, we will move to the third step in the process of eigenvector. The step 1 is you have to write the characteristic equation. The step 2 is what? Solving that equation, we'll get the roots. The roots are nothing but the eigenvalues. So step 2, we got the eigenvalues. Next step, we will move to the eigenvectors. So what is the third step in the process? For each eigenvalue, you have to consider the equation a minus lambda I of x is equal to 0. Okay, so that I am going to do. So first one, for each lambda, you have to consider a minus lambda I of x is equal to 0. So this is the formula we have. For each eigenvalue, you have to consider this equation, system of equation, and solve it. We'll get the eigenvector to the corresponding to eigenvalue. So first we will take it the lambda is equal to 1. So first what we will get? Lambda is equal to 1, we will find out. So a minus 1 I x is equal to 0. But we know what is the A? A is the given matrix. What is the I you have to take it? I you have to take it the corresponding identity matrix. So 1 times I is nothing but I. So what is the A? The A is, the first row of A is what? So 1 here I will write for this. So A we have here, this is what 1 0 minus 1 1 2 1 2 2 3. So what is the I you have to take it here? I the corresponding unit matrix, identity matrix will take it. 1 0 1 sorry 1 0 0 0 1 0 0 0 1. So this is what I3, identity matrix of order 3. Now just to subtract this A minus I. So what you observe it here, the impact is only on the diagonals. So remaining entries of A will get same. So just what you have to do, simply now subtract 1 from the diagonal, will get the A minus I. We'll do this one. So 1 minus 1 0 because of diagonal elements. So non-diagonal elements are same, 0 minus 1. So this is non-diagonal same. So this diagonal is what? 2 minus 1 1. This is 1 because of non-diagonal same, 2. Now this 3 minus 2 is the, so 3 minus 1 is the 2. Here x is, you will take it as some x1, x2, x3. This is system of equation 0, 0. So this is A minus I. Then how to write A minus I directly? Just simply only subtract 1 from the diagonal elements. The remaining entries of A you can write as it is. Just check it. What are the remaining entries? 0 minus 1, 0 minus 1, 1, 2. This is what? 1, 1. This is what? But you have to subtract 1 from the diagonal. So 1 minus 1, 0. 2 minus 1, 1. 3 minus 1, 2. So this is. Then what you have to do is, now we can find this, then how to solve the system of equation. So we are familiar in the unit 1, then how to solve the system of equation, homogeneous system of equation or non-homogeneous system of equation. Now this system is what? Homogeneous system of equation. But we know that depends on the rank of A. If rank of A equal to the number of unknowns, then the system has only one solution, that is called trivial solution. If rank of A less than number of unknowns, the system has non-trivial solution. Here number of unknowns nothing but the x1, x2, x3. So number of columns is always represent the number of columns, nothing but the number of unknown, that is equal to the vector a capital X we need to find out. So just by once you know the rank of A, from that you will get whether the system has trivial solution or non-trivial solution. By using echelon form method, I am going to find the rank of this matrix. Just what is the echelon form? What is the echelon form? We know for echelon form you have to use the elementary operations for the echelon form or normal form, but here using only echelon form, using echelon form only, I am finding the rank of the matrix. For echelon form, you have to use the only row operations you have to apply. Only row operations. So here don't apply your column operations. We are following the row echelon form. Even column echelon form also we will define, but we are confined to the row echelon form. So and also here I am going to use some notation. This we already discussed in the unit 1. So once again I will recall this. I can recall this notation. So here I am going to use this 3 notation generally. Rij. R means for row we are using this one. So this means interchange of the ith and jth row. So this meaning is what? Interchange of ith and jth row. For example, if I use R13, if I use the notation means we are interchanging first and third row. Similarly, Kri. So this is what? The multiplication of the ith row by non-zero number k. Now next, this one. So addition of k times the jth row to the ith row. What does this represent? Addition of k times jth row to the ith row. Here k always should be taken the non-zero only. K will take the non-zero. So these are the notations I am going to use in the echelon form, and what represent that notation also just now I explained. Most of the time we are going to use this notation only. Similarly for the column, but here we are not applying the column. So for reducing the echelon form, what you have to remember this one. So here I will give one just like one suggestion, or you can take it as some hint for reducing the echelon form of the given matrix. So first what we have to do is using, suppose the matrix this one, using this as a key element, like in matrix let us say A11, using as a key element A11, below entries make it 0. By writing taking by appropriate row operation, you will below entries make it 0. Then next what we are doing, next using the next key element is what? A22. Using that, then below entries make it 0. So like that if you proceed, then automatically that will reduce us to echelon form. So in this process, if at all if you make it the key element is 1 in the easy way, the process will become very simple. So this is the additional hint for that one, or else sometimes it's not required also. That is depends on the problem, you have to look into that one. Okay. Now what we have to do is first, what you have to do is first make it, this is what? Key element. This is called key row. So this is what? Key element. First, if at all possible, key element make it non-zero. With respect to that one, below entries make it 0. Okay. Here look at this one. Come to this matrix. Now we have what we have here. This the first row. The first entry is 0. The secondary entry also 0. Then in order to make it this key element non-zero, better you have to change it, interchange. So what I am doing, interchanging R1. So this R1 to represent what? The interchanging of the first and second row. And also you look at this one. If you look at this third row is a multiple of 2. Better you reduce the complexity of that one. So 1 by 2 R3. 1 by 2 R3. Now the equivalent matrix is, so we are interchanging 1, 1, 1, 0, 0, minus 1, because we are interchanging first and second row. This is 1, 1, 1. Now we can use this logic. What is the logic? Using this as the key element. This as a key element. Which has a key element here? This is the key element. So this is the key element. This is the key element. Using this as a key element, below entries make it 0 by taking appropriate row operation. So we have to change this A21, you have to change, this is already 0. Only thing we have to change R2. So we have changed this R3. R3 goes changing to R3 minus R1. So using the R1 as a key row, in that the element is A11 is the key element. So with respect to the A11, below entries make it 0 means is already 0, so that I am not considering anything else on that one. So this is R3 I am changing. This is R3 minus R1. So next you have to write it this one. So the equivalent matrix what you will get. So we are changing only R3. So R1 1 1 1. So this is the 0 0 minus 1. Now R3 minus 0 0 0. Okay. So is it possible to make next ending 0 this one? Is it possible to make it 0? No, we cannot do that. Even if you try to make it 0 this one, from using this, again this entries will become come here. Okay. So therefore we reach the echelon form. We cannot reduce furthermore. So once you reach the echelon form, just look at the number of non-zero rows in this system, in the matrix. So number of non-zero rows is the rank of the matrix. So number of non-zero rows, what are the number of non-zero rows? So this is, so we reach the echelon form. So number of non-zero rows is what? So rank of A is equal to 2, and always compare with number of unknowns. How many unknowns we have? 3 unknowns. Number of unknowns. Therefore, the system has non-trivial solution. Therefore, the system has non-trivial solution. Non-trivial solution, or you can write many solutions also, right? Many solutions. Then how to obtain this non-trivial solutions or many solutions? So further what you have to do is, this whatever we have, this you will take it as the R. This is the rank. This is number of unknowns, you will take it as N. So then you have to compute the N minus R. So this is called number of parameters. So this will get the 3 minus 2, 3 minus 2 is equal to 1. Now what is the significance of this number of parameters? The significance of number of parameters is, in solving this equation, the system, how many unknowns assigned arbitrarily. So that will give. So among these 3 variables, by taking one unknown value arbitrarily, so we will get the solve the system. Okay. So from this you have to solve it. This you now from this now this is what? X1, X2, X3, 0 0 0. Okay. Now from this you can multiply this. What you get? The corresponding x1 plus x2 plus x3 is equal to 0. Here x3 is equal to minus x3 is equal to 0. Okay, nothing but x3 is equal to 0. But here we got n minus r is equal to 1. So we have to take one unknown as arbitrary. Now which one will take among these 3? Already x3 we got 0. Either you will take x1 or x2. Let so x2 is equal to k, then x1 will get minus k. Now therefore the answer is x is equal to x1, x2, x3. So x1 is equal to what we got? X1, the minus k. X2 is what? K. X3, 0. Therefore this minus 1, 1, 0, k. So this you can write it as x1k, where x1 is an eigenvector for lambda is equal to 1. So this is the way of finding eigenvector for the corresponding to eigenvalue. So by taking this equation, a minus lambda x is equal to 0, solving the system of equation, whatever the solution will get, nothing but is a eigenvector of the corresponding eigenvalue. Here I proceeded with what? Lambda is equal to 1. So we got the system. The system is solved it. So we got the answer. The answer is what we got is this one, x1 is equal to minus k, x2 is equal to k and 0. So therefore, and also then in How to explain this? The system has many solution means here what is the k here? The k is a arbitrary value or parameter. The keep on changing this value will get the many solutions. All the solutions are the multiple of this one. Multiple of the minus 1, 1, 0. So the system has infinitely many solutions, but linearly independent solution is only one. The remaining all infinite solutions are the scalar multiple of the minus 1, 1, 1. So therefore here x1 is the eigenvector for the lambda is equal to 1. Similarly, you have to find out eigenvector for lambda is equal to 2, eigenvector for lambda is equal to 3. So we'll move to the next one. The second one, for lambda is equal to 3. So what you have to consider? A minus 3i of x is equal to 0. A minus 3i of x. Just you have to subtract what we know. A already we know. We know I. I is what the identity matrix of order 3. So multiplying with 3, what will get? 3, 0, 0, 0, 3, 0, 0, 0, 3. So if you subtract 3i from A, the impact is only on the diagonal elements. So non-diagonal elements you are trying the same. Only the diagonal elements subtract 3. Okay, we'll get this one. 1 minus 3 is a minus 2. Okay, then 0 minus 1, because 0 minus 1 is a non-diagonal, same. The next one is the non-diagonal. Here with the diagonal elements of this A22 is the 2. 2 minus 3 is the minus 1. So this is also 1. Yeah. Then 2. Now we have A33 here, but what we have 3. 3 minus 3 is equal to 0. Okay. So this is the, after simplifying A minus 3i, x1, x2, x3. 0, 0. Will little bit quickly I will move this one. Now again what we do is better if at all in the process of, now what we do next, now you can reduce this A to echelon form. After reducing echelon form, see the rank of A. Depending on the rank, you will get the whether system has trivial solution or non-trivial solution. And one of the hint is what, if at all you make it easily 1, if you make it easily 1, the key element, the process will become easy. So but I am changing R1. Even without changing also proceed, but once the key element is 1, we can easily make it zeros the below entries. That is the idea behind making key element is 1. So I am interchanging the first and second row, the minus 2, 0, minus 1, 2, 2, 0. Okay, then what we do now? I am changing R2 plus 2R1. R2 plus 2R1 will become 0. Now what is the key? Now what is the key element here? The key element is, this is the key element. This is the key element. This is the key row. So using this one, below entries make it 0. This one make it 0 and this one make it 0. Okay. For that I am writing the appropriate row operation. R2 changes to R2 minus, next R3 changes to R3 minus 2R1. So the equivalent is, the first row is same, 1 minus 1, 0. So now multiplying the 2, 0. This is the minus 2, 2 minus 1, 1. So next, the minus 2 plus 2, 0. Minus minus plus, 2 plus 2, 4. Minus 2. Now look at this one. Here, this is the multiple better I am writing. 1 by 2 R3. So next what we will get? 1 minus 1, 0, 0, minus 2, 1, 0, 2, minus 1. So next what we do? Using this as a key element, below entries make it 0. So changing this entry, so R3 changes to R3 plus R2. So we'll get 1 minus 1, 0, 0 minus 2, 1, Now 0, 0, 0. So therefore, we cannot reduce furthermore, because even if we try to make it this one 0, again this entry will come. So we reach the echelon form. Therefore, what is the rank of A? The number of non-zero rows, the rank is equal to 2. You always compare with what? Number of unknowns. This is called number of unknowns. Number of unknowns. You have to compare with number of unknowns. We know this is R, this is N. Next, what we do? We have to compute N minus R value. This is called number of parameter. What is the use of this one? So how many unknowns will take arbitrary value? Based on that, we will take the number of unknowns arbitrary values. Okay, 3 minus 2. We got 1. So we have to take only one unknown, only arbitrary value. So what are the equations from this one? X1 minus x2, 0. This is minus 2x2 plus x3 is equal to 0. So from this you have to take the only one unknown arbitrarily. Either you will take it anyone, this one. Here better I am x2 I am taking as the k. If x2 is equal to k, then x3 what will become? Then x3 is equal to 2k. x2 is equal to 2k, and here x1 is equal to x2. So therefore it is also k. Therefore capital X is equal to k because of x1 is equal to x3. This is what? 2k. Therefore 1, 1, 2 k, where x2 is an eigenvector corresponding to therefore x2 is, in short form writing, eigenvector short form for lambda is equal to 2. So similarly you have to find out this, the last one was third one. For lambda is equal to 3 you have to find out. So same way you have to consider A minus. So we have to, what left? 3 we find out. What left the eigenvalue? The 2 we left it. We find it 2. Okay. First we calculated the first eigenvalue 1. Then actually I have to proceed with 2, but I forget that lambda is equal to 3. I computed. The leftover is, you will do it now. Lambda is equal to 2. You have to consider A minus 2i of x is equal to 0. So just A minus 2i means just subtract 2. So 1 minus 2 is the minus 1. 0 minus 1. 1. 2 minus 2 is 0. This is the same. 2, 2. Then 3 minus 2 is a 1. 3 minus 2 is the 1. This is the x1, x2, x3. 0, 0, 0. Okay. So again, better you can, already we have the key element 1 or minus 1, using this as a key element. Below make it 0. Now we can reduce, then R2 goes to, so R2 plus R1, then R3 goes to, then R3 plus 2R1. Now the first row minus 1, 0, minus 1, just add this 0, 0, 0, then 0, will get 2. This is what? Minus 2 plus 1 is a minus 1. So in the process of echelon form, whenever if you get any 0 rows, will bring to the below only. Okay. So then you have to interchange this one, R2, 3. Because we are familiar this echelon form, the unit 1, so that I am moving a little bit quickly of this one. 0, 2, minus 1, 0, 0, 0. Now we reach the echelon form. We cannot reduce the furthermore in the process. Once we reach the echelon form, just see the rank of A. What is the rank of A? The rank of A is equal to 2, number of unknown 3. What is the n minus R? 3 minus 2 is equal to 1. So the significance we know, the number of parameter we got 1 means you have to take only one unknown assigned arbitrarily. So what are the equations from this one? Minus x1 minus x3, 0. This is the 2x2 minus x3 is equal to 0. So let better you take it x2 is equal to some k. Then x3 is equal to 2k. And from this, what is the x1? x3. x1 is equal to minus x3. So therefore, x1 is equal to minus 2k. Therefore, x is equal to x1 minus 2k, x2 k, 2k. Therefore, the minus 2, 1, 2, k. Therefore, x3k, where x3 is eigenvector for lambda is equal to 2. Sorry, this is the lambda is equal to 3. Make it correct. The second what we have done is for lambda is equal to 3. The last one is for lambda is equal to 2. Therefore, we got the eigenvectors for the each eigenvalues. So this is the process of finding eigenvector of a matrix. So first what we have to do is first write the characteristic equation. The second step, find the eigenvalues by solving the characteristic equation. The third step is for each eigenvalue, you have to consider the system of homogeneous system of equation a minus lambda I of x is equal to 0. Solving that will get the solution. The solution is nothing but the eigenvector of the corresponding eigenvalue. So thank you. I am ending the session today.
Like, share and subscribe. Hit the bell icon for more updates.